Good morning, student. Today I will discuss with you about Chapter 5 on Architecture 1 to 2, Architecture Delineation. In this chapter, you can learn something about orthographic and parallel drawing, isometric, and something in the drawing you used to see in the real field. First of all, I need you familiar with few of the definition in drawing. If some student study architecture design already, this one they know. But for some student, they had the first time to learn for architecture major, and this is few definition they should know before they start drawing. The first one, you should know about the plans, elevation, section, and you should know that the plan is shown on of the area from the projects with the wall, the window, the door, everything you see few feet on the top from the plan. Elevation is the one you develop from the floor plan, and it's have the height, so that's why they call that elevation. You see the height from the projects. The section is the one it's similar with elevation, however they show more detail about the structure. For example, you can see the structure inside from the wall, the structure inside from the roof one, the door, the window with the height of the building, of course, and after that you see something more interior material from the structure. You can see insulation, you can see more layer about chipboard, drywall, something like that. So you call that a section. And plan, elevation, and the section are orthographic drawing. Usually it's two-dimensional. One design professional often used for parallel sketch as well as the other type from the sketches to help them to visualize their design, because in the design you need to see many faces from the projects, not just in front of the projects. We need to see in the back side or the rear side, on the right or the left side, and after that interior. So that's why many things you need to know before you design. The best way to develop for your visualization skill is to practice, because when you practice you can see the relationship between orthographic and parallel drawing. Orthographic, that means you look directly straight from that project and you draw back. Parallel drawing, you can see many different size from the projects. The ability to develop rough freehand sketches in the orthographic parallel conversation process will enhance visualization. When you have the freehand sketch and you combine between orthographic and parallel conversation, you can finish the process, and this make you increase for visualization your views. Honing your skill in the visualization of simple block form will enhance your ability to understand the building form shown in the later parts of the chapter. Now, after you know few of information, you can see some of the plan. They explain more about orthographic and isometrics or parallel drawing. So if you see the first one, you see this is the floor plan, and you look on the top from the building down. So this is the roof plan. So you see the roof had the ridge right here, the slope on this side, the slope on this side, and the other way you see the small roof right here. It slope on this way and slope on the other way. So now if you stand right here, you look at the building, you look straight in front of the building, you see something like this. When you project the line wall right here, the line from the roof right here, This is the ridge one, the highest one from the roof one, and after that the slope down like this. And you have something with this one, but 90-degree angle. So that means when you stay here, you look this one will be sloped like this. But now you look at here, so that's why you see the ridge one. That means the highest one from the roof, and after that lower. This is the opening right here. Because this is the roof one, so you cannot see the elevation. That means the height from the building. But when you show an elevation, this have the opening right here. And this one is the high from the opening, and the other ridge one, the highest one, is this one. So when you project, you can see like this. You project line like this, they call that construction line. You can see the ridge one is right this, the highest one from the house. When you draw elevation like this, you call that orthographic. That means you look straight directly to the building and you draw like this. It's 2D. 2D, that means you see the height and the width from the projects. So now on this one, if you stay here, you look here. That means you're on the right side, you look the building. And the first one, you see the small roof like here, is this one. Because the ridge one is right here. So when you stay here, you look at this one, you see the ridge one right here, and this is the slope from the roof one right here. And open right here also. So you see open right here. Now, when you stay here, you look at this one. You cannot see the slope from the big roof, but you can see the highest one from the ridge one is here. And the lowest one from the roof one is here. So if you stay here, you can see the lowest one is right here. And the highest ridge is right there. Okay, if you stay here, and if you stay here, you can see that the ridge one is this one. And after that whole roof right here, that the slope roof is right there. Okay, so either you stay here or stay there. You see directly 90 degrees from where you're standing to look at the projects. And you see like this or like this, depend on where you stand. Now, because this one to show two of them, the width from the projects and the height from the projects, so you call that 2D. And because you look straight on there, so you call that orthographic drawing. So now, exactly the same projects, but you look in different way. For example, you stay here, and you look this one and this one. You not to stay here, you look stay there, and you look both sides. Stay there, and you see the angle. That means you create another view when you do elevation. And you see that's the angle right here and the angle right here. So that means you stay in the corner from the projects, look in the projects. For example, you stay here, you look at this side and look this side. So now, you see that's the angle you create this, and you make the projects is look like different angle, look like different view from the house. Before you stay here, you look here, but now you stay in the corner, you look both sides. And that's what you call that isometric. That means you not look straight from the building. You look at some angle and you make it have the height, the width, and after that the depth from the building. So you call that isometric. Both sides is the same angle. Same thing like that. If you stay in different view, that means different angle, and to look at the building, you can see many different kind from the building. You see that's the angle right here, and the angle right here is different. That means depend on your standing, the point you're looking for the building, you can create many different view from the buildings, and you call that the parallax. Okay, so now you go with another one. You usually see on of the projects system, they have 4 elements. The first one is the object. The object still where you look at this. The picture plane, that means cover whole of the projects in one of the plane. The viewer, you, when you stay there, you look at the projects. And the visual rays, that means where you look at the projects, many lines you can go from your to look at the projects. combine between your eye to the projects. They call that visual rays. Visual rays are the projection line from the observer eyes. That means you to various points on the view object or the scene. Perspective exhibit projection that are the variety of the angles to the picture plane and display the characteristic of the point convergence. They show converging side plane. That's the project one. In the design process, two-dimensional Multiview help us envision and communicate what the composite three-dimensional form will look like. That means when you look at the 2D and you view many different ones from the projects, and you can communicate that's for 3D. Three-dimensional form will be there. The plane view is essential to create both isometric and the plane oblique drawing for the interior space. Many plane view, they is very essential for you can create the isometric like you see before and the oblique drawing for interior space. This is one example. For the one they have definition. When you stay here, this is the station point or the standard point. When you look at the projects, the project is right here, but when you look at this, you look everything on the plane. So you see that the projects show here. That means the one you can see is right here, and this one they call that the plane. And on of the light between you and the projects, you can see that from here you look at here, from here you look at there. The one you see through the projects from your eyes, they call that visual rays. So that means 4 elements you can see that your eyes, plane, visual ray, and objects. Okay. So now if you look this one, the projects can be like that. So when you draw that, you can see in the front face, you can see on the side face, you can see the top face, and sometimes you see in the rear side. So they call that the perspective. You need to know something more. In professional practice, the plane is always available at the common scale. For example, they say that 1/4 inches equal 1 feet 0 inches. That means the scale you usually see on the drawing. They use that scale to draw the floor plan. Isometric are more commonly used for building exteriors, usually outside, where interior are the best display with the plane oblique. That means this one just the behind one if you do for exterior, and you can do interior on the oblique. The procedural rules always construct the wall and the roof outline first. That means when you draw the elevation, after you do the floor plan, you need to create the wall and the roof in the first one. With the multitude from the vertical and horizontal element is a most efficient to construct each elevation separately, no matter how complex the building. Follow the basics principle of the projecting to the plane configuration upward to exact elevation height. That means you need to follow the scale how high from the building, and you need to do that one. If possible, horizontally or vertically explode elements should not overlap. Try at the best, don't do overlap between the one you draw before and the next one. Don't do overlap, because you do that, the people when they look at this, they don't know which one is yours and which one is the copy for another one. This is some of the compare when you draw from 3D. That means you do for the isometric. You can see that the width, the height, and the depth. You can see it's look equal. That means you see 3 different one size is the same angle. When you look at this. But some kind you do dimetrics. That means you draw something is less than or more than. For example, you have here 1:1:2 ratio. That means you do some kind like the width and the depth equal, and the height you do maybe smaller, so that's why you have 3:4 for that one. And the other one you do 1:1:7/8. That means you have some kind like higher than the other one, 7/8 here with depth and height. This is some of the ratio when you stand or you view at different angle, a different side. You have the ratio like this. It's different. When you look 1 point, if you look straight, right, you see one face of the building. 2 point, you look can see 2 point. I mean the width and the depth. And 3 points, if you see some more on the height from the building in different angle. The concept for the expand view in the both plane, oblique and isometrics is frequently applied to building with 2 or more floors. If you have 2 or more floors, you want to expand more view on that one, and that's the way how to draw. Both expand and explore view allow us to see interior makeup from the building. In this sense, they are quite similar to cutaway view. If you have many things you need to expand on the view, you can do interior by cut the view, so you can see many different ones from interior. The rooms are defined by the series of the curving walls, courtyard space, or floor to ceiling window, and the private terrace. When you create the rooms, they define like the series of the wall, the ceiling, the window, and every close like this, and you call that the rooms. Isometrics up and down view can provide the great detail for visualizing interior space. When you do isometrics, you can have more views in up and down, so that means it make you have more visualize for the interior. See in many views from different vantage points at one time give a quick comprehensive overview of any structure. When you have many views in different vantage points, and that you can give more overview for whole of the structure. This is multi-view from single view drawing. For example, you have the floor plan like this, and you see on the roof one, it is the top one, and you look at the upper line right here, they show the wall. You see opening right here, this is the door, and on the side they have many windows. You see the cross one like this is the roof one. So in this one, you can see that on the wall plan, you can see the floor plan like this with the wall, the door, and you can see the roof one. Now you look at the front face, some elevation. That means you look right here, you look at here. You can see this is the building. This one is the slab roof, it's right here. And you can see whole thing here is the rich one, and you see right there. So when you do project line, you start from here, from the wall outside, exterior wall, you can draw this one. Outside here, you can draw this one. After you do projects from here to there, and here is the window in front up here. After that, you show the slab roof in the center, so you do center line and you up right there. And after that, you connect that to the point in the roof one. The roof one is outline one, so you can project this one here. Same thing, the roof line right here, you can go like this, and you do the slab one. In the back side, when you stay here, you look outside beside of the slab roof, you can see another ridge right here. That's another backside roof, and this is here. Combine together. So this is the roof plan. You can see the slab is right there. After that, the ridge is center, so the ridge is center right here. This is the roof line. This is the roof line. Okay. If you look at the front face, now you look at the side. That means you stand here. You look at the floor plan in this way. You see the wall right here is here. It's here. and the wall right here is there, and both sides here is the roof one. If you do perpendicular, you can draw like this, and you can draw the window in front of that. That means you look at this side, you can see the door right here. Okay, the height from the roof is similar. And if you see on this side from the house, you can see exactly the same like you see on the right side. You see the left side. It's right here. It's similar, but it has one window. And in the rear side, that means you look in the back, you look at the floor plan, you look in here. Exactly, it's look like the front side. It's like this, but it has no window. In the back side here, no window. Okay, so that's the 2D. That means the orthographic drawing. But now, same building, but you look at different angle. You can create from isometric like this, and you can see like this, and or you can see oblique. That means you see one of them is perfect, like 2D orthometric, and the other one is some view is smaller, and you can see that oblique is high behind this one. And you can see the matrix. That means you have angle from the house. Okay. So now this is some of the multi-view examples, so you can look over, or you can see more reference about isometric, oblique, dimetric, and isometrics. This is the floor plan, and you can see this is elevation, the high one like this, and this is the side plan. When you look very earth view, and you can see the building look like this. This is different kind from elevation. A little bit about the stair. We have isometric and oblique. If you look at the isometrics, and you can see the stair on angle. You can see that. You see angle right here, angle right here. And after that, the plan for the oblique, that means some of the stair will be high in very angle, and after that it's not in in look at the view. So they say you look at they call that the oblique, very angle, and some of them high. This one you can see the stair, but this one you can see some part it's high from the angle. This is the angle they show you for 15, 30. This is 15, this is 30, and after that the ratio between side by side when they're drawing. Another example, and this one we have one assignment for this one. Look like this one. This is the floor plan. You see, this is the floor plan. The floor plan show the wall, the door, and the window. The window right here, the window right here, the door, and you call this one the floor plan. Now, if you increase from this one, you create 4 feet high from the floor plan, and you create one elevation like this. And isometric for both of them is 30 degree. You can start right here, 30 degree, and you up 4 feet. After that, you draw the line for this one. You measure with the window, because you cut from 4 feet, so that's why you see half from the window. And the other side, you draw this one by dimension from here to here, and you draw it nice. This is the door, so you measure from here to here where you open the door. This here from here to here, and how wide from the door. After that, you go in front of this one. You measure this one, and this line is parallel with this one. So if you create this one before 30 degree, this line will be parallel with this one, because on the floor plan this one parallel with this one. And you measure from how big is it, and you draw this line. This line is parallel with this one. So on isometric, you need to show this one parallel with this one, and you create this one. High up 4 feet. After that, you draw another line for the high elevation from the wall. After that, this is the curve. This is the curve, so you draw the curve. Okay, and continue with this one is behind, so you can go like this behind. Okay, so you go everywhere like this. That's the isometric 30-30. If you change, you need to do for 45-45 isometric, but the angle is bigger, and you can do this one 40-45, and you can see, you know, more interior from the building. Okay, this is another example, so you can see few of them. If you look at the roof one, it looks like this. They have two parts like this, and if you look in front of that, you can see the highest one is right here. After that, you have the slope one, and this one is the one is low. So when you stay right here, you look at this one, you can see this one, highest one is the best one, and in the center is lower. This one is low, so you can see like this. And when you look at elevation and with the angle, this is isometric. You can see one of them is look the front face, the other one look the angle, and you can see the highest one is right there, and the center is the lower with the slope. The slope one is right here, slope like this, with the high one right here, but they are slope there. Okay, and if with different angle, 40, 30, 45, 60, and you change the angle, so you can see many views from one building with the different ratio. This is another example, and it will be one assignment later. So the first one, you have the roof one, and the second one, you have orthographic. That means you see straight from the building. You can see the roof right here, the roof right there, and after that, the small part right here with overhang. It's like this. On the elevation, the overhang right here. And this is the slope roof. Slope roof, you can see the slope right here. And the other side, you cannot see on 2D, but this is the slope one from the other side. And on this one, you have the ridge right here, the ridge right there. After that, they lower down. And this is the slope one, this is the slope one. And this one, they go straight, some here, and slope down. And if you look at this side, you can see the ridge one is right here. This point is right there, the roof one. If you look at here, ridge here. After that, this one, a slope here. Straight wall and slope more. That's the slope more right here. And after that, let's go straight. In this part, when you look at this side, you can see the part right here. So this is the part right there. Okay. This one, everything right here, you create for 30 degree, and you draw this one. This is one homework later. I think it's number 5, number 6, something like this. That's assignment. So now this is orthographic. Go straight to the building, here and here. Now, the homework is you need to create isometric 30 degree, 30 degree. And you need to create exactly the same right here. So you look at the face right here, exactly this one. And the face right here is on this side, in this side. To look at this one. So 30 degree. It's not hard. You just create the first line for the Z. That means the height from the building first, and you create 30 degree right here, 30 degree right here. After that, you start for the projects. First one, you measure from here. Look at this, the gap right here, and you need to have the gap right here. Stop, go straight. That's means right here and right there. So go straight, you look at this one, this side from here to here, you measure that and you draw this one. Stop, straight. Combine parallel with this one, with the line from 30 degree. And you look at this. It drop inside. That means it's, drop up inside. So you need inside there. That's inside the line. And you measure from here to here. Stop. From there to there, stop and go straight. The elevation look like the one you create right here. Okay, after that you have parallel line with the line you created before, not here, and you measure how far from here, stop. You measure from here to here, stop, straight again. Okay, so you go here. Now the ridge line is the one right there, so you go with this one on this side. You start the same thing. You measure from here to here, and you draw on here, but this one is just inside, so you have this one. Go straight, connect that, the first part. Now the second part, you measure from here to here, you go with this one from here to here, and you draw the line. After that you go straight, straight. On up, the elevation right here you can take from this one. Highest ridge is this one, highest one is this one, and this one is the highest one right here. This one is low, this here, and this one is low more here, and the top one is the part right here, and you create this one. After that you go parallel line with the 30-degree line, go straight like this, and you measure from here to here. After that you stop right here to here, stop, and do the line parallel with the one you create for the roof. Here, measure from here to here, and how much is it? Do like this one. This one different scale with this one, so you can see like that. And after that, slope right here, that's the straight one right there. The slope one right here is the slope one right there. And finally, you have the detail one for the wall. That's here. When you look at this one, we have 1, 2, 3, 4, 5 from here, and you create 5 of them. Measure from here to here and start from here to there. The door, measure right there, and you draw the door. The overhang, you see the overhang right here, and when you draw, it's like this. And this one in the part from the window outside, in front of that, so you can see the frame outside from that, the storefront window. This is the little window right here. It starts from here, and you can do parallel with this one, and straight line, and parallel with this one. Okay, so this is one homework you will do later. This one is the model from this one. Okay, so in the picture right here, you can see that some of the roof one, you have A, D, because you see in the roof one, B front face on elevation, you call that B, and the side one, you call that C. Now you look on the top one, you see the ridge one is right here, but this one, they didn't show you the different heights from this one, except you do look at this side. When you stay here, you look at this one, and you see that is different. This one higher, this one is lower. C face is the face right here. When you look at this side, B face, you can see the drop line right here, and you see the maximum one is the B in the this face, B. After that, it's lower on this one, drop to D. So this one is high, this one is low. Okay. So if you look at the oblique, you can see that's this one in the face one, top it's high, and after that the bottom is high, drop down for D, lower for the face C. So face C is this one. This is 40 degree, 48 or 45 same degree, but this one they do different angle, so you can see like that. That's the different part when you look at elevation. Something with that, we need to construct from the first one. This is exactly the project from the first one. So now you look at the oblique. When you draw density 2D, like before I explained to you. Now this is degree angle, for you can see isometric, and you can see this one. This one you change the angle, so you can see the oblique one, few part it be high, And when you look at the top one, when you cut between, before you draw the drop, the roof one is look like this when you do for both. Okay, this is the way how do you contrast from the first one on the roof one. When you look down, you can see the roof like this with the two posts right here. So now you start to straight like this, so you can show different face from the angle. Start like this, and everywhere. Just parallel line and vertical line for make sure how high from that one elevation, and you combine together to get this one. Finally, you can combine some of the height to make the floor plan for the building. This one the way you start from the top to the bottom one. And this one is another view when you do the oblique. When you start right here, it is you look at the front face, the true shape. But if you do elevation oblique, you can show like different angle, for you can see the other side from the building. And the non-vertical for Z axis oblique, that means you do more about the Z axis, the one the height from the building. You change the view from that one. Another example from isometric. If you create some kind like the curve or oval or the circle, the first one you need to create for the angle. For both of them, this is a vertical one, horizontal one, sorry, and you create two equal angle line. After that, you measure for this one with this one is equal, and you draw two parallel lines together. And this one you call that diameter of the circle before you draw the circle. Now you select the midpoint between them. This one you select midpoint, and you connect the top one to the midpoint one, each of them, so you can see like that. We start to do the curve from the midpoint to the midpoint, and finally combine the rest of them by the curve. So you have the point for the tangency, this one. And if you create the box like this, do the same thing. That means you start to have trapezoid, and after that you create the midpoint from each of them, combine together with the top point, connect with the middle point, and you do all of the face look like this. Start with the curve between middle point first, this one first, and after that go with the other curve. Okay, this is one of the example from the building with the curve shape. Another one with the curve shape, the model, and the floor plan, elevation cut off. Other example from the circle. When you draw that from the circle up here, and after that on the top, they create many circles on there. Model. This one is one you do for the oblique 45 degree. When you create one the project, this is a different one, and you can see the deck outside, and you can see interior one, some of them from the roof one. That's another one. Okay, these are some of examples, so you can see how can they create the curve. It's non-linear form, that the form is not linear, so you need to create the curve. And how do you do that? You just create the midpoint and combine together. This is the floor plan. And when you do elevation, you look at the top on the side one. After that, you create for the form. 1, curve line, 2, curve line, and 3 is the angle one. Form combined together. Another example from this one, the floor plan, not the you need to additional axis. That means you do the floor plan first, and after that you have another axis, the as for the floor plan, and how to erase this on the front. That beside of the big floor plan, you have additional axis for you can create that on the elevation. This is another example from non-vertical. They do the vertical is different height, and the axis Z is so different. You can see that's on of the building is different height, not the same. This is another example for exam. Expand the view. You can have many different kinds from the view from the building before you create. This is the floor plan, and if you see this one is this side, this one you drop off inside, and after that, that's one for elevator. For second one, this one a little bit gap in here from the floor plan. And they say when you develop each of them, for example this part, you want the second point from the second level from the stair right here, you can move it up on up the building if they want to do exactly the same area with the first one. They can create from the corner from the wall, the up. That means the part right here will be the second floor later. Okay, so more example for this one. When they want to expand from the oblique, you can see that they cannot plan from the one right here, and they can look far from the building if they want to do the same, or they want to change something in there. Explore from the view, so you can see that. They can create for many levels. If they do the same, they can do the straight one for the project line, and they can create many levels from the floor. Okay, so that's it all for the chapter 5. Basically in here we have 2 assignments will be coming up, so I suggest that you read very careful for the chapter, and after that practice many times for the orthographic and the isometric drawing. We have at least 2 assignments will be covered from the chapter. Okay, thanks so much for watching, and see you next time.